Hello and welcome back to Zig's Math Lessons, continuing our study of differentiating the quotient rule. If h of x is a quotient of two functions of x, like f of x over g of x, then h prime of x is the derivative of the numerator multiplied by the denominator, subtract the derivative of the denominator multiplied by the numerator, all divided by the square of the denominator. Well, gee, that's a lot of words. Suppose we just said if h of x is a quotient, then its derivative is the top thing prime times the bottom thing minus the bottom thing prime times the top thing over the bottom thing squared. And in Leibniz notation, it would look like this. Top thing prime times the bottom thing minus the bottom thing prime times the top thing, all divided by the bottom thing squared. Let's differentiate a quotient. Solution. Consider the function to be f of x over g of x. And since it's the first time we've used this formula, let's write out the formula. And now let's sub into the formula. So it will be f prime of x, which is the numerator, 5 times the bottom, 5 times 4x plus 3. So top thing prime times the bottom thing minus the bottom thing prime, which is that 4 times the top thing, all divided by the square of the denominator. Simplifying, multiplying things out, collecting like terms, and we have dy by dx, 19 over 4x plus 3 squared. Let's do it again. Differentiate another quotient. We see a quotient, we realize we're going to need the quotient rule. We can assign meaning to the numerator and denominator, call them f of x and g of x, write out our formula. The first couple of times you use a formula, you probably want to write it out. And sub into it. Top thing primed is 6x squared times the bottom thing, minus the bottom thing primed is 2x times the top thing, which is that 2x cubed minus 3, all divided by the square of the denominator. Multiplying it out, collecting like terms again, and we have our simplified dy by dx. You may or may not choose to common factor out the 2x. This expression is also good. Example, let's go again, find the equation of the tangent to the curve, y equals 4x minus 12 over root x at a given point, 4, 2. And I'm always curious if the point given is on the curve given. If I sub 4 in here, I'd get 16 minus 12 is 4, and if I sub 4 in here, I'd get root 4 is 2, and 4 over 2 is 2, which is this y value. So yes, this point is on the curve. Always curious about that. Solution. Well, we're going to have to differentiate a quotient. And so now that we have that, we can go top thing primed, which is 4 times the bottom thing, minus the bottom thing primed, which is 1/2 x to the minus 1/2, times the top thing, all divided by the square of the denominator. Now x to the 1/2 times x to the 1/2 is x to the 1. And now it boils down to algebra. We have two terms in this numerator. We could split those terms. And when we do so, we have 4 root x over x on the left side, subtract. And the reason we split the terms was so that we could simplify this half and this x to the negative half. The 2 will join into the denominator, and the negative sign on the x puts it also in the denominator and under a root sign. A possible next move might be to perform the operation of subtraction of fractions with a common denominator. And that will be 2x root x. And ask ourselves, what did I multiply x by to get this? 2 root x. So I have to multiply 4 root x times 2 root x, which will be 8x. Subtract the 4x, subtract the negative 12, and follow the algebra. Pause the video if you need to. Follow the algebra. We have our derivative. So we have a curve, we have a point, we have a derivative, and we're asked for the equation of the tangent to the curve at the point. Bringing it all forward. The curve, the derivative, the point. So taking the x-coordinate from the point and subbing it into the derivative. You have to sub it into the right spot. So it will be 4 times 4 plus 12 over 2 times 4 root 4, like this. Doing the math and the algebra carefully, we get m, the slope of the tangent. Reduce it. And now we have a point, and we have a slope, and use y equals mx plus b. Y from the point equals m, x from the point plus b, a little bit of math, you got b equals minus 5, we got slope, we have our equation of the tangent to the curve at the point. Example, find points where the function has horizontal tangents. Then use technology to make a graph showing these points. Solution, well, we'll have to differentiate and set the derivative equal to 0 because the tangents will be horizontal and we know that the slopes will therefore be 0. Differentiating top thing prime times the bottom thing minus the bottom thing prime times the top thing. So what we have here is top thing prime times the bottom thing minus the bottom thing prime, which is 2 times all of this to the 1 times the derivative here, times the top thing, all divided by the square of the denominator. We're going to set this derivative equal to 0. We could work hard on simplifying it, but we're going to set it equal to 0. Now, the key is when a fraction equals 0, the numerator equals 0. So let's just set the numerator equal to 0. So we'll put a 0 here. And while we're at it, dealing with this numerator, why don't we common factor out an x plus 1 because it's in both terms. So common factor out x plus 1. That leaves an x plus 1 here because there's 2 factors of x plus 1 times this. So it'll be 3x squared times x plus 1 minus 2x cubed. At this point, we can realize that there's 2 terms in these square brackets, and x squared is just begging to be common factored out. So let's common factor out x squared. And that leaves behind 3 times x plus 1 minus 2x. Multiplying out the square brackets within the square brackets and simplifying, we have x squared times x plus 1 times x plus 3. Which tells us that x must therefore be equal to 0 or negative 3. It can't be negative 1 because that's outside the domain of this function. X cannot be negative 1. So when we see this x plus 1 factor, it doesn't generate a solution. However, x can be 0 or negative 3. Since we know the x-coordinates, we know the points. So one point is 0, 0, and the other point is the result of subbing negative 3 in to the function. So we'll have negative 27 in the numerator and 4 in the denominator, like that. So those are the points where this curve has horizontal tangents. 0, 0, and negative 3, negative 27 over 4. Notice negative 27 over 4 is almost negative 28 over 4, which would be negative 7. So this is actually negative 6 3/4. Let's take a look at it. There it is right there, negative 6 3/4, when x is negative 3. And there's the other point, the origin, 0, 0. And this blue line is the curve. Y equals x cubed over x plus 1 squared. The points shown are the points that have horizontal tangents, and you can sense that that's true. And this is an example of using technology to make a graph. I used MathGV for this, and I highly recommend it. It's easy to use, a little bit of a learning curve, but look what can easily be done with it. Moving on, the position of an object is given by a function. Find the time, possibly plural, when the object is at rest. Solution, the derivative of position is velocity. And we know that when the object is at rest, its velocity is 0. So set the derivative equal to 0 and solve for t. Well, there's s of t, rewritten. Root t is t to the 1/2. Top thing primed times the bottom thing minus the bottom thing primed times the top thing over the bottom thing squared. Splitting two terms, putting the 2 and the root t on the bottom again, and setting it equal to 0, performing the operation of subtraction of fractions with a common denominator, gives us t squared plus 1 minus 4t squared. Only the numerator is of interest because it's equal to 0. So, setting the numerator equal to 0, solving, and we have t equals 1 over root 3, or possibly root 3 over 3, which is the same thing. That is the one time when the object is at rest. Find the derivative of a quotient. Top thing prime times the bottom thing. Now the top thing prime will be 3 times all of this to the 2 times 3. And I've bracketed it here. 3 times 3x minus 1 to the 2 times 3. Top thing prime times the bottom thing minus the bottom thing prime is minus 1 times the top thing is copied, all divided by the square of the denominator. Now take a look. This numerator can be factored. I see 3x minus 1 squared. I see 3x minus 1 cubed. So 3x minus 1 squared comes out common factor. Leaving behind, well, take this term and remove that factor. You have 9 times 1 minus x, which is 9 minus 9x. Because it's 3 times 3, 9, multiplied by this, 9 minus 9x. And 2 of these 3 factors are out. So this is actually plus one of these factors, which is 3x minus 1. Simplifying, and we have it. This 2 came from common factoring a 2 out of these brackets. Common factoring is a theme here. Let's do it again. Find the derivative of, now it's not a quotient, but it follows our theme. Solution. First thing primed times the second thing. Now the first thing primed is 3 times t squared plus 5 to the 2 times 2t. So up to here is the first thing primed times the second thing plus the second thing primed, which will be 4 times 3t minus 2 to the 3 times the derivative in there, which is 3. So up to here is the second thing primed times the first thing. And our theme is common factoring. Let's look at all of this. Well, let's first simplify it. 3 times 2t is 6t, and 4 times 3 is 12. And now looking at the factors, I see t squared plus 5 squared. I see t squared plus 5 cubed. So t squared plus 5 squared comes out common factor, as does 3t minus 2 cubed, because there are 2 terms here, and they each have a 3t minus 2 in them, and we common factor out the one that has the lowest exponent. And so now the common factoring will look like this. 6t and 12 will take out the common factor of 6. T squared plus 5 squared, t squared plus 5 cubed will take out t squared plus 5 squared. Always the lower one out of the 2. 3t minus 2 to the 4, 3t minus 2 to the 3, take out 3t minus 2 to the 3. And that will leave something in square brackets. What it will leave will be the residue, stuff left over when we've removed t squared plus 5 squared and 3t minus 2 to the 3 out of this, and remove the 6 as well. That will be in the square brackets, and the residue from this term as well. And what is this residue? Well, it will be a t times 3t minus 2. So it should be a t times 3t minus 2 for this term, the residue. And, well, I divided out a 6 out of this 12, so that'll be a 2 left over. And a t squared plus 5 left over because we only took 2 of these out, and there's 3 of them here. And now this square bracket needs to be simplified. It's multiplied out, and like terms collected. And now we have the simplified common factor derivative. Let's do it one last time. It looks like a complicated looking quotient. Differentiating. Top thing prime times the bottom thing minus the bottom thing prime times the top thing over the square of the denominator. T squared plus 1 appears in the denominator, and it appears in the first term of the numerator right here, and it appears in the second term of the numerator right here. And so each term can be divided by t squared plus 1. This 4 will become a 3, this will cancel, and this will become t squared plus 1 to the 1. Next, we can begin the process of common factoring. We have 2 terms in this numerator, and I see that there's a 4 in common, so 4 will come out. And I see there's a 3t plus 5 in common, so 3t plus 5 cubed will come out, leaving behind the residue. When we take all of this out, we're left with 3t squared plus 3. When we take this residue, subtract, now there's a 3t plus 5 still there because we only took out 3 factors of 3t plus 5, so there's 1 left. And the 4 has been taken out so that this t is left over as residue. Simplifying the square brackets, and we've done it again. We've differentiated a complicated quotient, common factored, and simplified it. If you like the presentation, then please subscribe and tell your friends and help me grow my channel. Thank you very much. I appreciate it a lot.